So here is an example that I am going to show. First of all, let's talk about this discrete case. So in this case, we are tossing two coins. Let's have this coin. So I have one. Let's find another one coin. Where it's at? Oh, I got it. So now in this coin, suppose I take x as the random variable, okay, and I want to find x represent tails. Okay, what is the probability that we are getting tails is the probability of x. Okay, so the outcomes are head tails head, and tail. Okay, and x is I told you that getting a tail. So now we are going to draw a graph for the same. So the probability for x equals to 0, that is no tail is occurring, that is occurring only 1 out of 4 times, so we are getting it as 1 by 4. Similarly, you can find probability of x equal to 1 and 2. With these data in mind, let's draw something in graph. So we made this graph, we made this beautiful coin here, we have these values with it, and now let's represent 0 will give me 1 by 4, this thing, 1 will give me 2 by 4, right, and 2 will give me 1 by 4 again. So this axis is showing me probability of x, and this axis is going to give me x. Okay, so now marking this thing, let's draw. So drawing the blocks, we are going to find this area, and this area is going to give me the sum as 1. Okay, I got the sum as 1. Suppose I would have taken this as f of x, that is cumulative distribution. So what would have happened? So I will add this extra block in 1 to 2. This extra block will be added like this. Similarly, if I want to add these extra blocks in here, so I'm getting something like this and this. Okay, you can see that when f of x is equal to 1, when it is 1, when we take the limiting factor, okay, we take the limiting factor, x goes to infinity. If you go towards infinity, everything after 3 will be 0, so we'll get this thing again and again if you are representing this as f of x. So limit x tends to infinity, f of x will be 1. Similarly, limit x tends to negative infinity, what will be f of x? This will be everything behind 0. So if you will go to the extreme left, then you will find nothing. Okay, nothing is added up. So this is a clever way to find cumulative distribution function. Okay, this is the idea. That was an example. So let me show you something in continuous case. So what happens in continuous case? You identify certain intervals like this. Okay, then you try to plot the graph, and you will then find the area. So if this will represent probability, this will represent x. Okay, now this is an example of some continuous case where the random variable is continuous. Okay, in that case, suppose we are drawing this, everything less than 0 we are getting it as 0. Okay, and after 0 this thing is behaving like e power minus x. This is e power minus x. So what you have to do is you have to find this area in order to find the integral. Now let's see f of x and examine it. What is f of x when limit x goes to negative infinity? Clearly it is visible that it is equal to 0. Now what happens when limit x tends to infinity? We find f of x. Just put it here, that is limit x goes to infinity e power minus x, and this approaches to e power 1 by e power 0, that is 1. So you are getting 1 for fx at x tends to infinity, and x tends to minus infinity, you are finding fx equal to 0. So this is also an example of continuous random variable. Sorry, this is not continuous random variable, This is cumulative distribution function. Okay, I hope you got that. So let's end the video here.